Assalamualaikum warahmatullahi wabarakatuh. Good morning, ladies and gentlemen. Let me introduce myself. My name is Bambang Novianto. There are another authors, Mr. Johan Suryanto and Mr. Kalamullah Ramli. The title of our paper is Vulnerability Analysis of Internet Devices from Indonesia based on Expo data in Sudan. This is the outlines in this presentation. First is the introductions. We will talk about project science, Sudan search engine as numbers, clustering. Next is methodology. We will talk about data collection, data cleaning and integration, data featuring, data mining, and evaluations. The third is results. We will show the statistic of ports, operating systems, product services, domains, IP addresses, organizations, clusterings for AS numbers in Indonesia. And the last is conclusion. First, introduction. Nowadays, the internet has been one of the most transformative and fast-growing technologies. The growth of internet-enabled devices has increased the interest for the security of data. To collect data from internet-enabled devices, Project Science was created. Project Science collects data by using the Sudan search engine. Sudan is a search engine that scans the internet to find open ports. Sudan is a reference to sentient, hyper-optimized data access network. Sudan's information is considered valuable when attempting to discover critical systems that are directly connected to the internet. There will be a positive or negative aspect of Sudan. It depends on its user intent. Sudan can be used as either an assessment portal or as a weapon for hackers to scan targets passively. Based on Project Science report in 2014, there were 211 countries identified based on the IP addresses harvested from the search term discovered. The highest countries are United States with 616,994 IP addresses. It is about 33.75%. The second highest is Germany with 280,248 IP addresses. It is about 15.33%. And the third highest is China with 112,114 IP addresses. It is about 6.13%. And another country. How about Indonesia? Unfortunately, the number of IP addresses harvested from Indonesia in 2014 is very small. It is about 7,182 IP addresses. It is about 0.328% from 2,186,971 IP addresses. Because of this, we propose an initiative to gather all information for all autonomous system numbers in Indonesia. An autonomous system is a group of connected internet protocol under the control from single administrative entity. Then we use clustering algorithm to categorize all autonomous systems in Indonesia. Clustering is one of the most widely studied problems in machine learning and data mining. Clustering is a process of grouping a set of unlabeled objects into classes of similar objects. The result of this study can be used to warn all organizations in Indonesia that manage AS number to be aware of the potential vulnerabilities that can be exposed from Sudan. There are many different kinds of research to assess internet-enabled devices with Sudan. In 2016, Ercolani et al. Visualized IP addresses and open ports from Sudan. They extracted all IP addresses that were identified from Iran. In 2017, Ali et al. Used Sudan to present vulnerability scanning for IoT devices in Jordan. They pointed out the critical cyber attack against IoT and presented statistics about vulnerable devices in Jordan. In the same year, Williams et al. Assessed IoT devices exposed on the internet with Jordan. However, their focus were on the vulnerabilities of webcams, smart TV, and printers. In 2019, Ray et al. Surveyed methods of assessment using method. They presented the impact of Sudan to identify internet-connected devices for good and bad purposes. However, none that focused to analyze and gather all information for all IS numbers from Indonesia. The next outline is methodology. For methodology, we use knowledge discovered in databases. First is data collection. Second is data cleaning and integrations. The third step is data featuring. The fourth step is data mining. And the last is evaluations. For the first step, data collection, we create a data set by collecting all information in Sudan for all IS numbers from Indonesia. Daily downloads of scans have been parsed and inserted into CSV file. The dataset was derived from December 2019 until January 2020. In the next step, data cleaning and integrations. We clean our data from blank spaces. We integrate all CSV files for each IS numbers in Sudan into a single file. Then we convert semicolon CSV into comment delimited CSV for input to Splunk Data Analytics for visualizations. The next step, data featuring. For the efficiency of processing, we need to keep the number of feature space as low as possible, but should represent host behavior carrying rich enough information. We found the following features that represent the exposure quantity in Sudan are number of queries and size in bytes. The next step, data mining. We use K-means algorithm to cluster all IS numbers based on the level of exposure data in Sudan. K-means algorithm is the most commonly used clustering algorithm. Last, evaluations. We evaluate vulnerability of IS numbers from Indonesia based on the exposure level in Sudan. We provide several visualization and statistics about ports, product services, operating systems, and domains. This is the fields of data from our dataset. Data, domains, hash, host, host names, info, IP, ISP, organizations, operating system, port, product, text, timestamp, transport versions. For the K-means clustering, K-means clustering algorithm is the most commonly used clustering algorithm. The distance measure is generally used is Euclidean distance. The objective functions to be minimized is called sum of square error. The cluster centroid C can be updated as follows. The next is our results. We will talk about ports, operating system, product services, domains, IP addresses, organizations, clustering for IS numbers in Indonesia. We observe 1,699 IS numbers in Indonesia. There are 624 IS numbers information that we collect from Sudan, such as IP addresses, ports, product services, domains, operating systems, and organizations. We gather 89,715 queries of Sudan into single files. The size of the file is 267 megabytes. This is the statistic of ports from Indonesia in Sudan. There are 272,457 information about ports. From these, there are 12,787 unique ports. Port 80 is the highest port from Indonesia in our datasets. It is about 13.95%. The second highest is port 2000. It is about 12.162%. The third highest is port 53. It is about 10.824%. And another ports from Indonesia. For statistics of operating system from Indonesia in Sudan, we collect 2,141 information about operating systems. From 2,141 information, there are 79 unique operating systems. Linux 3.x is the highest operating system in this dataset. There are 768 information about Linux 3.x. It is about 35.871%. Second highest is Windows Server 2012, standard 9600. It is about 9.453%. And the third highest is Windows 7 or 8. It is about 7.94%. And any others operating system from Indonesia and Sudan. Next is statistic of product or services from Indonesia and Sudan. There are 98,152 information about product services. From 98,152 information, there are 409 unique products. Microtic bandwidth test server is the highest product in this dataset. The information about product services are as follows. The second highest is Apache HTTPD. It's about 16.5%. The third highest is OpenSSH. This is about 7.782%. And another product services from Indonesia. Next is statistic of domains. There are 111,632 informations about domains. From all these informations, there are 3,350 unique domains. The highest top-level domains is .id. The number of unique domains of .id is 1,881. With the total information, it's about 85,238. The second highest top-level domains is .com. Numbers of unique domains of .com is 1,242, with the total information 17,498. The third highest is .net. The number of unique domains of .net is 190, with the total information 8,190. And another top-level domains such as .arpa, .tv, and .biz. Next is IP addresses on organizations. For IP addresses, there are 272,461 information about IP addresses. From this, there are 145,543 unique IP addresses. Unfortunately, for security and security reasons, we cannot publish all specific IP addresses in this paper or this presentation because this information will refer to specific organizations in Indonesia. For organizations, there are 271,731 information that includes the name of the organizations, such as internet service providers, agencies, and universities. From 271,731 information, there are 790 unique organizations. The highest organization in our dataset has 64,505 informations. It is about 23.7%. Unfortunately, we also cannot publish the name of organization in this paper for security and secrecy reasons. Next, we cluster the S numbers from Indonesia in Sudan. In our dataset, there are 1,075 IS numbers that are not exposed to Sudan, and 624 IS numbers that are exposed to Sudan. For 1,075 IS numbers, we will categorize this as a class 0. That indicates there is no information in Sudan yet. We will cluster 624 IS numbers with k-means algorithms into the classes such as low, medium, and high exposure. In this picture, we can see the blue nodes, the green nodes, and the orange nodes. The blue nodes indicate the low exposure data in Sudan. The green node indicates the medium exposure in Sudan. And the orange node indicates the high exposure Sudan. There is only one in this orange node, and there are 9 in the green nodes and others in the blue nodes. The conclusions: we successfully create a dataset about all information of IS numbers from Indonesia in Sudan, such as 12,787 unique ports, 79 unique operating systems, 409 unique products, 3,634 unique domains, 145,543 unique IP addresses, and 790 unique organizations. Based on the clustering result, we have 4 classes of IS numbers. First is class 0. There are 1,075 IS numbers in this class. No information in Sudan yet. The second one is class 1. There are 640 IS numbers in this class. It indicates that the exposure level is low. The third one is class 2. There are 9 IS numbers in this class. It indicates exposure level is medium. And the last one is class 3. There is only 1 IS number in this class, that the exposure level is high. This information can be used to warn the organizations that manage the IS number in Indonesia to be aware of the security and the threats to their systems. The future works for this research. We can initiate national vulnerability assessments and intrusion detection systems based on information in Sudan for Indonesia. Thank you.